Now we will see together what was equivalent for us or okay. Anyway, we will use it with everything, but now let's see what its components are. Here we will find all the functions available in the relay, whether they are protection, control, or internal functions present in the relay. The point here is that when you open any of these functions, you will find underneath it everything that comes out of this function, which we refer to as, and as an example, just to understand how things work, for instance, I opened my function group here, and when I opened it, I found underneath it there is, and inside I find a set of DC that can enter or exit this function. All right, so here I will find that, for example, the word has a specific or number in, and then I find the type of this function. All right, that's nice. So what are you going to do with this function or all these functions? Or how are you going to program them? Let's say that if I do this for hour, then I have, in simple terms, it means the source, it means my destination, so it means the source that is coming to feed what's inside this function. To say this function and the destination means where these functions or the virtual output of this function is going to. All right? Great, my dear. Okay, let's open the source, but if I open the source, I'll find that 3 columns appear below, just so we understand how things are going, so we don't get confused and feel like there are too many things. I'll find here binary input up to this point, then function keys, then CFC. Under binary input, I have the base module. I don't have an extension module. If I had an extension module, it would have shown me. The base module is set to input from 1.1 to 2.3, and the function keys are present in the base module from 1 to 8, and then I have CFC. So what does this mean? It means that I can program my binary input, which is coming from the source below, to program it with a virtual input for any function. Let's assume, for example, you have something like a circuit breaker. Anything for me. And what does the position need? It needs input. So I will program this input here. All right, okay. It depends on the type of input. What does it mean depending on the type of input? There is an input like, for example, a word called, and you have something else. And do you have something else? The double point. The single point means that if you right click, you can program it as active high or active low, like the SIPROTEC 4, meaning active high when voltage is applied to it, or active low when voltage is removed from it. All right, when does it become active? Nice. Okay, that's if it's a single point. If it's a double point, like for example the position of a circuit breaker, then I need an input for close and an input for open. Nice. Okay, so here, when you come to program this input, which is double, when you right click, you don't find high or low, but you find it says close high and close low and open high and open low. Meaning, do you want your closing to happen when this input is high or when the input is low? And you will have to program again because you need to program as a case. Okay, that's for the, you need to program 2 as double. Okay, that's for the input. Okay, the function keys. If you want to use the function keys to activate something specific, this might be less commonly used because we can use the function key to perform actions like escape or navigate to a specific menu in the relay. However, using it as a button to block a function or something like that carries a risk, of course, because if anyone presses it accidentally or does something, it could cause a problem for me. And the last part is the CFC or continuous function chart, which we explained before in SIPROTEC 4. Now the continuous function chart here is different. We will see its programming later compared to SIPROTEC 4. Here, you don't specify that the source of this function is coming from the CFC. You will find that the entire CFC column is hidden. What you program there in the CFC will be reflected here. It will show you, for example, that the signal, let's say the source of the signal is, for instance, this coming from the CFC. But in SIPROTEC 4, we used to indicate here why it tells you why, so that when I go to the CFC, I can tell it to take this signal or output this logic to that signal. So you had to route it first to the CFC. All right, so you can program in CFC, but here no. all the signals, as we will see later, are already available in CFC. So what you program in CFC will be reflected here in your matrix. So don't worry about the CFC column. You don't need to program anything there. Okay, that's regarding the source, E. Now, regarding the destination, this is a bit larger. Here I find the binary output. You can program the binary output of the different functions. Let's assume, for example, you open it here. You can open any function or pick up and program it with any binary, or you can program it with a set of LEDs. We will notice that the relay has 16 LEDs, unlike the older relays, which only had 14 LEDs. You can program it with any binary or make it, and you can program it also with a set of, we will notice that the relay has 16, and unlike the older relays which only had 14, okay, this is the output. I can click on it to minimize it, and I can minimize the LD. So I've reduced the number of open columns in front of me. Nice. After that, I will find the fault recorder here. In the past, in the SIPROTEC 4, you used to right-click on the signal, click Properties, and tell it that you want this signal to appear in the disturbance recorder. This time, no. This time, the disturbance recorder appears here in front of you. All you have to do is right-click and tell it whether you want this signal to be routed in the disturbance recorder or not. So of course, it's like we forget the signal, for example. Someone might not right-click and do Properties, which would take time. Here it's easy. You can right-click and do what? Route it. But is this the only option, that it's routed here? No, this is not the option. We will take a step forward, and when we come to the disturbance recorder, we will return to it again. You can through the settings of the disturbance recorder. If we go to the settings of the disturbance recorder, it tells you that the fault recorder is triggered with the pickup, meaning any function that operates internally and gets a pickup will initiate or trigger the disturbance recorder. However, if you set it to user-defined, when I return again, but if you told it, when I return again to the information routing and come to this signal and right-click, a new option will appear. Previously, I only had routed, meaning it was recorded here. It will show you trigger or trigger and routed. You told it not to trigger with any pickup or any trip or anything. No, you said user-defined, and you are the one who specifies what triggers it. So here, it requires you to go to the matrix and see which signal you want to trigger it. And do you see it only being recorded without triggering? Or do you want it to trigger? Or do you want it to trigger and also be recorded, which is also available to you? Okay? So this is our story. And we will return to volt record when we explain. Okay, let's go back here to your information routing. So this is your disturbance recorder, and then you have the logs. Inside these logs, you have something called the operational log, something called the fault log, and the user-defined log. Another user-defined log is the ground log, and so on. So here you can simply add a set of signals in the user-defined log, and then through the relay screen, you can access these logs and see the things you programmed. When a fault occurs, you can see what events happened and what you instructed to be recorded here. Then you have, and D, which you might not need. Of course, this is what reflects, as we agreed. In addition to the display also includes anything you are using. For example, like here, you will find a sign, meaning there is something inside that is programmed here with. So of course, this is also a part you need to know. The word here means there is something programmed here to go underneath it to see where the programmed part is. Go down. You won't see anything here tied to something connected to it. When we come here to see ours or to see what is connected to us, all right then. In short, this is how the emails are. You have done a large set of configurations for the input, output, and LED, and you want to come to the final setting to review these parts and see if you have done them correctly or incorrectly. Let's open it like this. Here's the input. So you want to remember what you have done and what you're missing. You can simply use the filter here to tell it you only want what is routed, meaning only the things that are programmed. So it will remove any function that is not programmed with anything. Anything internal within the function that is not programmed with anything will be removed, leaving you only with the things that are programmed. Is that clear? So if we look here, these are all the things that are programmed. So if you come here, for example, here's the function group. There's something programmed here, which is why it's visible to you. You open it here. In the backup, what will you find here? Somewhat. For example, what is programmed here? In it you will find what you have, depending on the type you are using. So you can just see. Only see. Only see. So depending on what you want here, or I mean the things that are not programmed, you can see. Consequently, this makes it easier for you to review the work you have done. Of course, as something you should also know, some people don't like working with a large matrix in front of them. You can click here and it will tell you to just show the let's see now together. What does it mean, let's see now together? It will include the input column for you, instead of being written as 1.1 or 1.2. Did you see how it was supposed to be? No, now here is the word circuit breaker. 1.1, 1.2, you saw how it was supposed to be, right? No, now here, for example, in the circuit breaker, here is the word circuit breaker. And you go here, for example, here is the circuit breaker. Here, it focuses on the word ready to program the bot. You tell it active high, it will tell you why is it wrong. You can't just say high or low. It will respond, incorrect format, the format should be H and N. NN is the column number. I tell it H 1.2 to program bot 2 and press enter. It told you that NN is for the column number, meaning which input. For example, I tell it H 1.2, so I have programmed input number 2 and press enter. Alright, so that some people don't like to have the entire matrix in front of them. Similarly, the same applies to the binary output. For example, I want to program this with the output content, so I come and tell it unlatch, for instance, and then I tell it, for example, 1.4 like this. That's it. So this is the keyed programming method. This is my programming. So, in simple terms, this is my information routing.